BGP peering with loopback addresses in NXOS or BGP peering with via loopback interfaces. Okay, in this scenario, I'm going to show you how we can configure BGP neighborship between two loopback interfaces instead of using the two, for example, physical interfaces in the NXOS. The configuration is so similar to the configuration of the BGP peering with loopback address in the iOS, but we have also some differences. Let me to show you how we can configure this neighborship via the loopback interfaces. Let's start from the NXOS one, the switch one, the conft, okay, conft, the first command. Host name is switch one. Then we should go to the IP addressing of the, for example, physical or logical interfaces. Interface ETH11, the first interface. The first command is no switch port. And now we have one routed port. After that, we can configure the IP address. IP address is 10.121/24. This is the first command. Then no shutdown. After that, we should go to the interface ETH12. The IP address in ETH12 is 10.2.1.1, okay, 10.2.1.1/24. And after that, first we should enable the routed port, no switch port, then IP address 10.2.1.1, and after that, no shutdown. That's it. Also, we need one loopback interface loopback 0. IP address is quad1. IP address quad1/32. And after that, we can check the IP addresses of the interfaces. Show IP interface brief. As you can see, we have three interface, one loopback and two Ethernet interface, Ethernet 1.1 and also Ethernet 1.2. All of these interfaces now are in up state. Okay, very good. Let me to go to the NXOS2. Here is NXOS2 conft. Okay, conft. Then the host name is switch2. The first interface is ETH11, no switch port. After that, the IPv4, the IP address, okay, is 10.122. The IP address of the ETH11, 10.122/24, and also no shutdown. After that, the other interface, ETH12. Again, no switch port, again, IP address. This interface's IP address is 10.2.1.2/24, and after that, no shutdown. This is the configuration of the ETH12. And finally, interface loopback 0, IP address quad2/32. And let me check the IP addresses to show IP interface brief. As you can see, we have three interface with three IP addresses. Okay, very good. The next thing is that we should configure two static route because we need to connectivity between the loopback IP addresses. Let me starting from switch one. Now we don't have connectivity between these two loopback. For example, ping quad2 with the source of loopback 0 with the for example source of quad1. As you can see, we don't have connectivity. Ping quad2 with the source of the, for example, IP address of quad1. Okay, we don't have connectivity. After that, we need, for example, one static route. Let me show you, or two static routes, because we need to use static routes to have two routes between the loopback 0 address of the NXOS1 and NXOS2. conft IP route, the first IP route command. Okay, for quad2/32, you can use the 10.122 as the first next stop, and also 10.2.1.2 as the second next stop. Now assume that show IP route. Now we have two routes for the quad1. For the quad2, the first is from the, for example, 10.122, and the second from the 10.2.1.2, and both of them are static routes. Okay, very good. And now we should configure again these two static routes in the switch 2 IP route quad1/32 10.2.10.1.2.1, and after that 10.2.1.1. Okay, now we can check show IP route. Yes, we have two routes for the quad1, both of them are static. Let me to check the connectivity between these two loopback interfaces, pin quad 2 with the source of the quad 1. Okay, let me check. Yes, we have connectivity. Now we can configure the BGP neighborship between these two loopback IP addresses. And then router BGP, the first command. The first command is you should enable the feature BGP in NixOS. Feature BGP. Now we can configure the BGP. And then router BGP, then 65,000. The first command, the recommended command, it's not mandatory, it's recommended. Configuring the router ID, BGP router ID or router ID. The first command is router ID, quad 1. The second command is enabling the, for example, enabling the address family IPv4 unicast. You need it, address family IPv4 unicast. And after that, you should configure the neighbor. The neighbor is quad 2, neighbor quad 2. Then we should configure the remote AS. Remote AS is 65,001. You know that for configuring, for establishing neighborship between two loopback interfaces, we need to use update source interface name, and because we need to change the source IP of the BGP packets or TCP packets. In iOS, I use neighbor IP update source. Here, I should use update source only because this configuration is under the neighbor mode, neighbor context. And only we need to use the neighbor, we need to use the update source, okay? Loopback 0. Also, in eBGP neighborship between the two loopback addresses, we need to use the eBGP multi-hop because the default TTL value is 1 and we need to increase this default TTL value. And here eBGP multi-hop 2. And finally, you should enable the address family of IPv4 unicast, for example, for this neighbor, address family IPv4 unicast. That's it. This is the configuration we should do in the NixOS for having a neighborship between these two switches. Let me to review the configuration. Router BGP 65,000, router ID quad 1, address family IPv4 unicast now is enabled, neighbor quad 2, remote AS 65,001, update source loopback 0, eBGP multi-hop is 2, and address family IP4 unicast now is enabled for this neighbor. Let me to go to the NixOS 2. In NixOS 2, the first command is feature BGP, you know, and then router BGP 65,001. Optional command BGP router ID is the optional command, router ID quad 2. Then address family IP4 unicast should be enabled, and after that we should configure the neighbor statement. Neighbor is quad 1, the remote AS is 65,000, the update source is loopback 0, and eBGP multi-hop is 2. And finally, address family IPv4 unicast should be enabled. That's it. Let me to check the neighborship between these two switches. Show BGP IPv4 unicast summary, okay? And yes, we have the neighborship between these two routers, and as you can see, the 0 prefixes received from this neighbor and the state is established. We can advertise some routes between these two routers. For example, in NixOS 1, I can configure another loopback interface and advertising it with the BGP interface loopback 1 IP address, for example, quad 10/32, and then in router BGP 65,000, okay, under the address family IPv4 unicast, I'm using this command, network statement, network quad 10, and for example, with the mask of /32, do show BGP IPv4 unicast. You can see here this route injected locally in the BGP table of the switch 1, and you can check in NixOS 2 BGP table, do show BGP IPv4 unicast. This is the NixOS 2. Yes, this route is received from the next hop of quad 1. This means that we have neighborship with the quad 1, and this is the neighborship between two loopback addresses in the NixOS. It's so similar to the configuration of the neighborship between loopback interfaces in the iOS, but we have a little difference. The difference is for example, configuring update source and also eBGP multi-hop under the neighbor context. Okay, in iOS we should use